This tutorial is going to cover esters for A-level chemistry. There are a number of different things that you need to know about esters. First of all, you'll need to know what they're used for, you'll need to know how to name them, how to form them, and how to break them down. Here we're going to start with naming esters. Now an ester is named in two parts. There is a side group here, drawn in purple, and there's a main part here drawn in red. So this ester has one carbon in the side group, so that side group is a methyl group. Now the main chain has 3 carbons in it, so the main chain is a propanoate. So that's a propan O8. So the suffix of an ester is an O8. The second ester drawn here, there are 2 carbons in the side group, so this is an ethyl group. There are 2 carbons in the main group in red, so this makes it an ethanoate. So we have ethyl ethanoate there. This ester has 3 carbons in the side group, so this is a propyl group. Now there's 1 carbon in the main chain here, so this is a methanoate. Now our final ester here has a slightly different side group. Here we have a phenol group as our side group. So this is a phenyl, and with 2 carbons in the main chain, this would be an ethanoate. So we have phenol ethanoate. Now there are many different uses of esters. Now esters have a characteristic fruity smell. So what they're used for is in things like perfumes and sweets and things like that to give them a particular characteristic smell or flavouring. So esters are also used as flavourings, as artificial flavourings to add different tastes, such as the taste of pineapple or apple or all sorts of different flavourings. Anything that you can think of, you can pretty much make artificially with an ester. Now there are many different uses of them. Another one is as a plasticizer. But there are lots and lots of uses, and you'll be able to find many of those online. There are a number of different ways to make esters that you need to know about for A-level chemistry. The first way that we're going to look at here is mixing a carboxylic acid with an alcohol, with an acid catalyst, heated under reflux. This will produce our ester and water as well. So our acid catalyst will be something like dilute sulfuric acid or dilute phosphoric acid. So let's have a look at an example of how you would actually go about this reaction. So I'm going to start off with ethanoic acid as the example. So this is ethanoic acid here, with our carboxylic acid group here as COOH. We'll mix it with an alcohol, and the alcohol that we can use here, let's start with methanol. So methanol is our alcohol. We'll use an acid catalyst. Now you'll notice here that I've drawn the main equation here, the first general equation, as a reversible reaction. Now these are reversible, and I'm only using a forward reaction arrow here just to show that we're producing an ester, because all we really want is our ester as a product. This is very important that the reaction is reversible, and it will make a difference, and we'll talk about that later on. But just to look at and focus in on making esters here, our carboxylic acid here will form our main chain. We have the double bonded oxygen there. Now this group here, this OH, is going to be part of the water molecule that's made on the other side. So we're going to make water there. The hydrogen from the alcohol here goes off and helps to form the water. And then the alcohol will attach as a side group here, and this will be a methyl group on the side. So this is H2O water produced. This is our ester here. This is our alcohol and our carboxylic acid. Now remembering the conditions here are heated under reflux with a dilute acid catalyst such as phosphoric acid or sulfuric acid. Now the name of our ester here is methyl ethanoate. So methyl ethanoate. Now the second way of making an ester is to use an acyl chloride, mix with an alcohol. This produces our ester and a hydrogen chloride as our waste product. Now you can see here for this reaction that the reaction is performed at room temperature. So this is an advantage over reacting carboxylic acids and alcohols which need to be refluxed and required an acid catalyst. Now because the acyl chloride is so reactive, you don't need to use the catalyst in this reaction. The other main advantage of this reaction is that it is no longer reversible, so you're going to get a higher yield of the product that you desire. Now let's have a look at a particular reaction here. So we'll start off with ethanoyl chloride, CH3COCl. So this is ethanoyl chloride. We use ethanol as our alcohol. This time, we'll have a slightly different ester from the previous example, but it will happen in exactly the same way. So this Cl here is going to be part of the leaving group, so this is a good leaving group. So the Cl leaves, the oxygen here will bind to the carbon, this hydrogen will go off and form HCl, so we've lost the H here from the alcohol, the chlorine has left, so that's removed, and our alcohol will attach here as CH2CH3. So those are our two products. This is not a positive on the ethyl group here, it's just I've run out of room. So our ester formed here is ethyl ethanoate and hydrogen chloride, fumes of hydrogen chloride, steamy white fumes of hydrogen chloride will be released as well. So let me just write that one down. So that's steamy white fumes of HCl. Now the third way of making an ester for A-level chemistry is to use an acid anhydride with an alcohol, again at room temperature, so you have the advantages over the reaction between an alcohol and a carboxylic acid, that it can be done at a low temperature. It's no need to reflux. The reaction goes to completion and we produce our ester, and this time our waste product is a carboxylic acid. So let's have a look at an example here. So I'm going to use ethanoic anhydride as the example. So this would be CH3, C double bonded oxygen there. I'm going to draw the rest of the anhydride in a different colour so you can see where the groups leave to. The alcohol I'm going to use is methanol, so CH3OH. As I say, the reaction goes to completion, so that's a big advantage. Our ester will form from the CH3, CO from the anhydride. The rest of the ester will be made up of the alcohol. So the hydrogen here will leave and join this leaving group to form the carboxylic acid. So our carboxylic acid is going to be CH3, COO, with the hydrogen from the alcohol being the waste product here. So those are our two products, mixing an anhydride and an alcohol to form our ester here. So this video has covered three key things about esters: how to name them, how to produce them, and some uses of them. The next video will cover the breaking down of esters using acid and base hydrolysis. Thank you for watching. Please make sure to like these videos, subscribe to the channel, and also really important that you share these as well.